Hello. In this video, we're going to take a look at a couple of examples using exponential and logarithmic functions. All right, our first example, we have the pH of a chemical solution is given by pH equals negative log base 10 of H+, where H+ is the concentration of the hydrogen ions in moles per liter. Values of the pH are going to range from 0, which is an acidic, and 14, which is an alkaline. What is the pH of a solution with 0.01 moles per liter? So we're going to put our concentration, this is our concentration of our hydrogen ions. We're going to plug that in for H+. So we're looking for our pH. pH equals negative log base 10 of 0.01. This one you can do without a calculator, or you can use a calculator to find this. Log base 10 is what we call the common log, and that's just the LOG button on your calculator. So that's going to be negative LOG of 0.01, and the log of 0.01 is negative 2, and then the negative out front is going to make it a positive 2. So if we have 0.01 moles per liter, our pH is going to be 2. If the pH is 0.001 moles per liter, so the exact same thing, we're just going to plug in, this time we're going to plug in log of 0.001, and on the calculator we can just do second enter and pull that up and go in and change that to 0.001. And we do get a pH of 3. And then our last one, 0.0001 moles per liter. And that one, when you plug it in, you will get a 4. Because this is the same thing as 10 raised to the negative 4. So log base 10 of 10 to the negative 4 is going to just be negative 4, and then that negative out front is going to make it a positive 4. All right, so what's happening to the pH as the hydrogen ion decreases? So as the hydrogen ion concentration is decreasing, our pH is increasing. All right, now we need to find the hydrogen ion concentration if our solution has a pH of 3.5. So now we're using that same formula, but we're plugging in 3.5 for our pH, and that's going to equal negative log of our hydrogen ion concentration. We need to get that hydrogen ion concentration by itself. So first we want to isolate that logarithm, so let's move that negative to the other side. So we get negative 3.5 equals log of H+. Now remember, this log is an understood base 10, so if we convert that to the exponential form, we're going to get 10 to the negative 3.5 is equal to that hydrogen ion concentration, and that's what we're looking for. So if we get a decimal approximation of that, 10 raised to the negative 3.5 is 3.162, and then don't forget this e to the negative fourth on the end. 3.162, and then e negative fourth. That means we're going to move the decimal 4 places to the left, and so we're going to get 0.00362. All right, if we want to find the hydrogen ion concentration if a solution has a pH of 7.4, remember our pH increases as our hydrogen ion concentration decreases, so our pH is going up. Our answer here should be smaller than this, but we set up the exact same way. We're going to plug in 7.4 for our pH. We're going to move that negative to the other side and write it as that log isolated, and then converting that to the exponential form. Our understood base is 10, so we get 10 to the negative 7.4 is our hydrogen ion concentration. If we plug that into the calculator, we get 3.98 times 10 to the negative 8. So that would be the scientific notation. We could also, it would be 0.0000000, 1, 2, 3, 4, 5, 6, 7. Then it takes 1 to get in front of that 3, so we'll have 7 zeros before we get to that 3. Alright, now let's look at an exponential function. So we have the atmospheric pressure on a balloon or an airplane decreases with increasing height above sea level. And so that's going to be in kilometers. So this pressure, measured in millimeters of mercury, is given by the function P of H equals 760 e to the negative 0.145 h. Find the height above sea level for an airplane experiencing a pressure of 290 millimeters per mercury. So that is giving us a pressure, so we're going to plug that in for P. So we get 290 equals 760 times e to the negative 0.145 h. And we're going to solve that. First thing we need to do is isolate that exponential. So we're going to divide everything by 760. And let's go ahead and get that as a fraction so we don't have any round off error there. That's going to be 29 over 76. Now we've isolated that exponential, we can convert it to the logarithmic form. And so when we convert this to the logarithmic form, our base is e, so that means we're going to have the natural log. Log base e is the natural log of that left-hand side is going to equal our exponent. And then to finish solving that for h, we're going to divide both sides by that coefficient, negative 0.145. So we're going to have the natural log of the answer that we just found, and then divide that by negative 0.145. And we get that h is 6.64. And our h was in kilometers. So the units there are going to be in kilometers. If we want to find the height above sea level for a mountain, if the atmospheric pressure was 613, we're going to start out the exact same way. Notice how it's just going to change this number that's in the numerator here. So we can go through that same process, or we can realize that that's going to be the same. We're going to get h equals the natural log of that 29 came from reducing the fraction, so we could just leave it unreduced. And that's going to be the exact same process we just went through. And so we can change this, and instead of doing an answer, it's going to be 613 divided by 760. And we get a height of 1.48 kilometers. All right, I'll see you guys next time.